Hey there, Grade 5 learners, and welcome to today's Explainer. I am so incredibly thrilled to have you here because today we are embarking on a really unique journey together. We're going to unlock the secrets of geometry, specifically focusing on triangles and parallelograms, and then we are going to use those exact math skills to help save real forests in a beautiful place called Lorente. Get ready to become mathematical stewards of the earth. All right, let's dive right into our steward's mission log for today. First up, the parallelogram secret. Then, finding base and height. Number 3 is the triangle area formula. Fourth, stewardship in Lorente. And finally, measuring to protect. Let's get to it.
Kicking things off with part 1, the parallelogram secret.
So, I want you to really think about this for a second. What is a triangle's secret identity? Like, if a triangle were a superhero taking off its mask, what other shape is hiding right there in plain sight? Any guesses? Let's find out. Okay, so step 1. Imagine a parallelogram. You know, that four-sided shape where the opposite sides are perfectly parallel? Its area is simply the base multiplied by the height. Pretty simple. Now, step 2. Picture taking a laser and slicing right through it with a diagonal line, from one corner to the opposite corner. What happens? Well, step 3 reveals that this one single cut splits the shape into two completely identical, congruent triangles. Literally two copies of the exact same triangle that fit perfectly together like a giant puzzle to make one parallelogram. And what this brilliantly illustrates is that every single triangle in the universe is, mathematically speaking, exactly half of a parallelogram. Moving right along to part 2, finding base and height. Now that we know the secret, the absolutely crucial thing to lock down is what we call perpendicular height. So the height is the shortest, straight line distance from the base all the way to the opposite point. And here is the kicker. It must always form a perfect 90-degree angle with the base. Think about it like when you get measured at the doctor's office. You have to stand perfectly straight up against the wall, right? You can't slouch or lean to the side. Shapes work the exact same way. The height has to be a straight drop down, never a leaning side. So here are your 3 golden rules for this. Number 1, you can actually choose any side of the shape to be the base. Seriously, if you turn the shape completely upside down, its area stays exactly the same. Number 2, always look for that perfect 90-degree angle. And number 3, measure straight up to the opposite point. As long as your base and height are locked together at that 90-degree angle, you are good to go. Now for part 3, the triangle area formula. It is officially time to turn that secret geometry knowledge into a literal math superpower. Here's the formula you're going to use all the time. Area equals 1/2 times the base times the height. You'll often see this written out as A equals 1/2 BH, or sometimes as base times height divided by 2. And honestly, this makes total sense now, doesn't it? Because we just learned a parallelogram's area is base times height, and our triangle is exactly half of that parallelogram. So we just multiply the base and height, and then cut it right in half. Boom. Let's do a super quick practice run. Imagine you've got a triangle with a base of 12 centimeters and a height of 8 centimeters. First step, we multiply 12 by 8, which gets us 96. But hold on, remember our secret. That 96 is the area for the whole parallelogram. To find just our triangle, we have to take half of that 96, which gives us our final answer, 48 square centimeters. And remember, you always measure area in square units. Okay, let's take these skills into the real world with part 4, stewardship in Lorente. So take a look at this. We're exploring a stunning, lush, tropical forest trail in the eastern Samar province. Now, to put this in perspective, almost 67% of this entire region is forest land. We're talking rough, hilly terrain, huge mountains, and incredibly dense vegetation. And these forests are absolutely vital. They act like giant sponges to absorb heavy rains. They provide homes for tons of wildlife, and they literally protect the human communities living down below them. Now, what's really interesting here is how these natural lifelines spread out across the province. If you look closely at the major river networks, you'll spot the municipality of Lorente, which is completely supported by the Lorente River. These complex water systems absolutely depend on having healthy, deeply rooted forest upstream. That's what regulates the water flow and stops disasters from happening. But unfortunately, these lands are facing some really serious threats. First off, eastern Samar is right in the middle of the typhoon belt, meaning they get hit by massive, destructive storms.
On top of that, there's a big issue with unplanned upland agriculture expansion, basically where forests get cleared out to make room for farming. And this general deforestation has historically caused some huge, devastating floods. Because of all this, local governments are stepping up to create what's called a Forest Land Use Plan, or a FLUP. The whole goal is to identify the exact areas that desperately need to be designated as protected forest zones.
And this brings us to a really powerful concept: respect for life and creation. This right here is the very heart of stewardship. Being a steward basically means you've been entrusted to care for and protect something incredibly valuable. By identifying and guarding these critical forest lands, the people of Lorente are acting as true stewards of the earth. And today, we are going to use the math we just learned to help them out.
Which leads us to our final section, Part 5, Measuring to Protect.
All right, here is your mission directly from the field. Imagine you are a junior steward helping to draft this forest land use plan. You've just been handed a map, and on it is a highly vulnerable, triangular-shaped forest plot right near the Lorente River. This plot desperately needs to be marked as a protected zone. The surveyors have done their part and measured it out for you. It has a base of 50 meters and a perpendicular height of 30 meters. So the big question is, what is the exact area of the land we need to protect?
Let's solve this together using our new math superpower. Step 1, we identify the parts. Our base is 50 meters, and our height is 30 meters. Step 2, we multiply the base times the height. So 50 times 30 equals 1,500. But wait, we definitely don't want the whole parallelogram, right? So step 3, we divide that by 2, which, remember, is the exact same thing as multiplying by 1/2. Half of 1,500 is 750. So the incredibly cool part here is that you have successfully calculated that exactly 750 square meters of vulnerable forest land will now be securely protected on that map. Great job, team!
By learning how to calculate the area of triangles today, you've seen firsthand how math isn't just a bunch of boring numbers on a page. It is an actual tool that can literally map out the protection of our planet. So I want to leave you with this thought. Look around your own neighborhood, your local parks, gardens, and green spaces. How can you use your new math skills to become a true steward of your own local environment? Think about it, keep exploring, and I will see you on the next explainer.